Dear students, today we will discuss on the topic of network elements, Ohm's law and the limitations of Ohm's law. In the previous class, we have discussed about what is the meaning of current and the units. The units for current is amperes. Next, the units for voltage is volts, and potential difference exists between the two bodies having potentials. The unit of potential difference is also as volts. Electrical power is the watts, represented in terms of watts. Today we will continue our discussion to see what are the various passive elements that are present in electrical circuits, R, L, and C, and active elements and statement of Ohm's law. So we have seen that electrical energy is nothing but the total work done in an electrical circuit in a given time. So if the time is T and electrical power consumed is P, power into time will give the electrical energy. So that power, uh, this power into time will be equal to V into I into T, and therefore energy is given by I square R into T. If you see the power, if it is expressed in watts, then and the time in seconds, then the units for energy is watt second. Because finally we have energy is equal to power into time. Energy is equal to power into time. So if this is in watts and this is in seconds, the unit for energy will be watt second. If power is expressed in hours and energy is expressed, sorry, if power is expressed in watts and time in hours, units for energy is watt hour. If power is expressed in kilowatt and time in hours, then energy unit will be kilowatt hour. Kilowatt means 1000 watts is 1 kilowatt. Okay. So in your house, we consume energy and every month we pay electricity bill. And that electricity bill is based on how many number of units we consume. So 1 unit of energy is equal to 1 kilowatt hour. 1 kilowatt hour. Okay. So that means if we use 1000 watts in 1 hour, that becomes 1 kilowatt hour. Then it is taken as 1 unit like that. So if you see the types of elements that are connected in a network is nothing but the interconnection of various electrical elements. Electrical elements can be broadly classified as passive elements and active elements. Passive elements and active elements. Passive elements are the one which consume energy like resistance, inductance, capacitance. Active elements are the one which give energy, which give power to the circuit or the elements. So here we have voltage source and current source. Voltage source and current source. Okay, so first we shall concentrate on passive elements. Passive element, first one is resistance. The resistance is represented by R. What does it indicate? It name itself indicate that it resists. So the opposition offered by a material or a substance to the flow of current, the opposition offered by the substance to the flow of current is called resistance. Is called resistance. What is current? Current is nothing but the flow of free electrons. If the conductor or the material opposes this flow of electrons through it, then we say that the material is having some resistance. How much value of resistance is there? That is represented in the form of unit as ohm. Okay. So the symbol of ohm is this one. So there can be a resistor to indicate that the material has a property of resistance. We symbolize like this resistance. Let us say, or it may have 1 ohm, 10 ohm, 100 ohms, 12.3 ohms like this. So if a resistance is connected between the terminals A and B, a current can flow through it. When the current flows through it, potential difference or voltage is developed. So it means that the resistance has voltage across it and current can pass through it. What are the factors on which resistance depends? Resistance depends on the length of the material L, area of cross section of the material. Resistance is uh, resistance is proportional to inductance, sorry, length of the material, and resistance is inversely proportional to the area of cross section of the material. You can see here length, and this is area of cross section. And another one is resistance depends on the property of the material, and that property of the material is called as the resistivity. It's called resistivity. So finally, we have an equation based on the material that as resistance R is equal to rho into L by A. So the resistance of a conductor directly proportional to A, inversely proportional to A, and it depends on the nature of the material, that is rho. This is called as resistivity or specific resistivity or specific resistance. The unit of resistance is ohm meter. The unit of this one, the unit of this resistivity rho is ohm meter, and unit of resistance is ohm. This one is length of the material, meters. Area of cross section, square meter. So finally, you'll get this one. Resistance also depends on the temperature. As the temperature increases, okay, normally as temperature increases, resistance increases. Okay. So next we have what is called as conductance. Conductance is the property of the material with which it easily opposes the flow of electrons through it. So that means this conductance is reciprocal of resistance. G is 1 by R. So this resistance R is expressed in ohms and G is expressed in mho. Okay, this is ohm and this is mho, indicating that it is reciprocal of this resistance. It is denoted by G. Okay, sometimes it is the units is also called as Siemens, represented by S. Another one is conductivity. The reciprocal of the resistivity is called as the conductivity. So here conductivity can be represented by sigma or G. Next, self-inductance. Self-inductance is like this. If, for example, we have a conducting material in the form of a wire, let us say it is a copper wire. Normally, we use a copper wire like in our house wiring and all. So, if current is flowing through it, the property of any conductor when it carries current is flux is produced around it. This flux is in surrounding the conductor. This flux is surrounding the conductor. Normally, this flux is distributed throughout and does not have any effect on the behavior of the conductor. But if the same wire is wound in the form of a coil, is wound in the form of a coil, then what happens? Flux around each conductor, each length of the conductor, what happens? Add up each other. We can visualize now a long wire is there. If I wound it, it may just take only this much space. So what is happening? Here the flux is distributed throughout. Now all the flux is available here only. So this flux concentrating at a single point or small region has influence on the behavior of the material. So what it does, this flux tries to oppose the change in current. So therefore, when the wire is wound in the form of a coil, it has an additional property to oppose the change in current. That property to oppose the change in current is called as self-inductance or inductance, and it is denoted by L. Okay, so this wire is already having some resistance. The same thing is wound here. So it has now got a additional property L. So this L depends on the number of turns, flux produced, and current passing through it. N into 5 by I. N into 5 by I. So this product N into phi is called as the flux linkage, and I is the current. So flux linkage per unit ampere, flux linkage per unit ampere will be the inductance value. Next, the other element. So the symbol for resistor is like this. No? The symbol for resistor is like this. Similarly, symbol for inductor will be like this. Okay. And represented by symbol L. The unit for L is Henry. Unit for inductance is Henry. The other element that is present is a capacitor. Capacitor is normally having two conducting areas or plates. and these are separated by a suitable insulating medium. Air can also be insulating medium sometimes. Paper can be there like that. So this symbol of capacitor is like this, represented by C, and unit is farads. Unit is farads. So any two conducting surfaces separated by an insulating material is called as a capacitor or a conductor. So what is its purpose? Its purpose is to store charge in a small space. So if we connect this capacitor, if we connect this capacitor to any voltage, then the current starts to flow, and that we call it as the capacitor current or charging current. And once the capacitor charges to supply voltage, the current stops. The conducting surfaces are called as plates of the capacitor, and insulating material is called as the dielectric. So air itself is acting as a dielectric, but that dielectric value will be very, very small, and hence we use suitable materials like paper, bakelite, and all to have suitable dielectric material or insulating material. That's it. Next, coming to the Ohm's law. Ohm's law states that the voltage across the resistor is directly proportional to the current flowing through it if the temperature is maintained constant. So for a given temperature, the voltage developed across the resistor is proportional to the current flowing through it. So V is proportional to I, and that proportional constant is given by R, and R is called as resistance. So V is equal to I into R. When the temperature increases, the resistance will change. So this resistance is dependent on temperature, given by R naught into 1 plus A into T or alpha into T. So that now for given temperature, V is proportional to I. Okay. So the symbol of R is like this, I and E. So there are some limitations with Ohm's law. Can we use this V is equal to I into R for all the cases? No. This is used only for linear elements. Okay. Used only for linear elements. In case of non-linear elements, what are linear and what are non-linear elements? In case of linear elements, voltage is proportional to current. If voltage increases, current increases. If increases, voltage will also increase. On the other hand, for nonlinear elements, voltage is not proportional to current. Voltage is not proportional to current. They may voltage may behave as a square of the current, square root of the current, one third of the current, like this. So in that case, the relationship between voltage and current of different values, and the relation is not unique. So if, for example, I have a characteristics like this. Okay, let us say this is B and this is I. Now it is linear. I can derive some relation between voltage and current, like V is equal to K into I, like this. It is linear operation. Now in case of non-linear, I may have like this: V is equal to I square by 2, or it can be square root of I by 3, something like that. Okay. So it is non-linear. The relationship between voltage and current is not unique. You may have a graph like this between the voltage and the current. You may have a graph like this. So it is not linear. So here the behavior is different, here the behavior is different, here the behavior is different. So the relationship between V and I depends on sign of V for absolute values of V. So there can also be negative value also. Can the curve can be like this. So in case of VA characteristics non-linear, you cannot apply Ohm's law. That is the main disadvantage of Ohm's law. But if not, this Ohm's law is a very, very important law, and it is used for all the calculations. Yeah. So dear students, today we have discussed on the concept of energy. Its unit is watt second or watt hour, okay, or kilowatt hour, like this. Okay. Next, network elements. We have seen passive elements R, L, and C. In coming classes, we will see the active elements also, like voltage source and current source. And we have also seen the statement and equation for Ohm's law and what are its limitations. Yeah. Try to answer these questions. A potential difference across 24 ohms resistor is 12 volts. So there is a resistor. The voltage across this is 12 volts, and the resistance R is 24 ohms. Okay, so V is given by like this. Now, what is the current passing through it? We have from Ohm's law, V is equal to I into R, and therefore I is equal to V divided by R, and that is 24 divided by 12 equal to 2 amperes. Very simple circuit. Next one, a resistance of wire is 20 ohms. So there is one wire whose resistance is 20 ohms. If it is stretched uniformly 8 times its original length. So if you can stretch this one to 8 meters, uh, the resistance of the wire is 20 ohms. What will be the new resistance if it is stretched uniformly 8 times its original length? If we stretch this resistance or a resistor 8 times, then what will happen to the resistance value? So for that, you can take this example. The resistance of a wire is R ohms. It is stretched to double its length. If I just double the length, then what happens to the new resistance value? The new resistance value will become 4 by R. Why? Because R is equal to rho into L by A. Now what has happened? Length has doubled, 2 into L, and area of cross section. What happens to area of cross section? So it becomes, the radius become half of it. So therefore we have pi R square. Square you will get, and hence finally you get 4R. 4 times the original resistance. So now at the end of the session, you should be able to define the passive elements R, L, and C, and active elements like independent voltage source and current source, and the state Ohm's law. These are the topics that you can refer in the textbook K. Umarao. Thank you, students.